All right, this problem assumes that we have proton info. So, and that'll be given. I don't expect you to have this memorized. For a proton, the mass is 1.67 times 10 to the negative 27. The charge is 1.6 times 10 to the negative 19 coulombs. And this problem is talking about a proton moving perpendicular to a magnetic field. So let's just set up a diagram for this. So I'm going to draw a region here. So these X's will represent the magnetic field directed into the page, right? X's are into the page, so I'm going to section this off. So this is a region of magnetic field going into the paper or into the screen. Okay, and then along comes a proton. So here's a proton, and then it comes in this way into the magnetic field. Now when the proton enters the magnetic field, which way is the force going to be? So to figure that out, you're going to use right-hand rule number 1, the flat hand rule. So your four fingers are going into the page. Your thumb is to the right, so the palm of your hand points up. So the force on this proton is going to be that way, but the velocity was that way. So what's that going to do to the proton? Is the proton still going to travel in a straight line like that? Not if the force is up. So what we found out, in our lecture on this, so the proton's going to start, it's going to curve upward, right? So now let's look at it. So when it's here, the velocity is that way. So if the velocity is that way, which way is the force going to be? Do flat hand rule again. So 4 fingers are into the screen. Yo.
I don't get any of this.
Well, did you have a more specific question? So, okay, so what I'm walking you through is this. I'm just going to tell you the end of the story is this. When you have a charge traveling perpendicular to a magnetic field, the force will always be to the center of a circular path. So look, let me switch colors here, because we got 2 vectors going on. The 2 vectors are force and velocity. So don't confuse these. So the red is velocity, the black is the force, right? So the proton, look at, hey, the proton comes into this magnetic field. The velocity is to the right, okay? When you apply flat hand rule or right hand rule number 1, so your 4 fingers are the magnetic field, your thumb is the velocity of the charged particle, the palm of your hand is the force. So it's going to be like this. The palm of your hand, when you do the right hand rule, is upward, right? So that's the direction of the force. So because the force is upward, the charge is going to curve upward. So now let's look at the charge when it's right here. The velocity is that way. At that moment in time, the velocity is that way. So now do right hand rule again. Okay, so your thumb points up, your 4 fingers are in. Which way is the palm of your hand? To the left. So the force is to the left. So what's the charge going to do? The charge is going to curve to the left. Okay, so here's the charge right here. So now let's look at the velocity again. So the velocity here, the velocity is that way. So do right hand rule again. So now your thumb is to the right. Your 4 fingers are in. So which way is the palm of your hand? Down. So dude, notice what's happening. We get a circular path, right? Basically the force is always perpendicular to the velocity. And that's a characteristic of circular motion. The force is always pointing to the center. Okay, so when you sum the forces for this proton, what's the only force acting on the proton? It's the force of the magnetic field, which we could label, let's just label it FB. B is magnetic field. All right, what is the sum of the forces equal to? MA. This is a special A, because why? It's centripetal. That's a centripetal. Okay, so centripetal acceleration is equal to V squared over R. So now, and then we plug in the equation for force of magnetic field. QVB sine theta equals m, and then centripetal acceleration is v squared over r. Okay, what's the theta here? The theta is the angle between the velocity and the magnetic field. What's the angle between the velocity? So the velocity is this way, or actually, when it first enters the field, the velocity is to the right, the magnetic field is in. What's the angle between in and to the right? 90. This is 90 degrees. Okay, and then sine of 90 is 1. So what we have, let me make some room. So what we have now is we got QVB equals mv squared over r. One of the v's cancels, and let's solve this for r. So r is equal to mv over qb. Now, we're solving for b, right? Sorry, it says determine the magnitude of the magnetic field. So we'll solve this for b. B is going to equal mv over qr. We have the mass of the proton. We got the charge of the proton. Now, how are we going to finish this problem? Well, they give us the period. It says here, it takes 1 second to complete one revolution. This right here, 1 microsecond to complete a revolution. That information is the period. So how can we work this into the problem? Well, look, for anything traveling in a circular path, velocity is what? The basic definition for velocity is distance over time. Dudes, what's the distance around one circle? 2 pi r, the circumference. What do we call the time for one circle? The period. This is true for any object in a circular path. That's the tangential velocity. So we're going to take that, plug it in there. So now we get magnetic field equals m 2 pi r over period divided by qr. The r drops out, and then we get 2 pi m over qt. Now we can solve it. So this is going to be 2 pi 1.67 times 10 to the negative 27, 1.6 to the 19, and then the period is 10 to the negative 6 seconds. So you plug that into your calculator, and you get 0.066. And then the unit for magnetic field is Tesla.